Hello, good evening everyone. Today we are I'm just going to post across a video which is on solving problems on a worksheet. So this worksheet has already been shared with you by today, and since we don't have much of time discussing the solutions for this, so I thought maybe I will share the solutions directly here and it might be helpful. Okay. Now, without wasting much of time, there is not any misconception. Okay, it is only the video uh, that I'm posting it across to share the solutions for the worksheet. Okay, so there's an equations of motion. So you have 4 equations or 5 equations of motion given over here. So the actual 3 equations, these are the 2 equations which we have already discussed in the classroom. Okay, so now first question: a car starts from rest. A car starts from, hey, where is the pen here? Yeah. Okay, a car starts from rest. The moment I see rest, let me magnify it. Right. Okay. A car starts from rest, which means what? U equal to 0. U equal to 0. U equal to 0. And it accelerates uniformly. Acceleration is constant. So which means you can use your equations of motion for 10 seconds, 8 seconds. T equal to 8 seconds. And it reaches a final speed. Final speed means final velocity, which is 16 meter per second. This is also given to you. What is the acceleration of the car? So which equation? You can use acceleration A is equal to V minus U divided by T. See, this is one of the equations of motion. Why should I use my equation of motion? Because it very clearly says it accelerates uniformly. What do you mean by acceleration is uniformly? It means the acceleration is a constant. Okay, so I can use this. Let me substitute these values. Value of V is 16, U is 0, divided by time is 8. So the answer should be 2 meter per second square. So this is the answer for it. Okay. Now, what is the average velocity of the car? Whenever the acceleration is constant, which equation can you use? You can use the average velocity is equal to u plus v divided by 2. This is your equation. You can use it only when the acceleration is a constant. You see, acceleration is a constant here. Now, plug in the values. What's the value of u? 0. What's the value of v? 16 divided by 2, which should now be equal to 8 meter per second. Now, this is a special case. Now, let us try the same problem with a different formula. What is the formula? The general formula for finding the average velocity is given by total displacement divided by total time taken. Total time taken. This is what we have. Let us use this method also. But before that, now you see, in order to do this one, I have this total time taken, but I don't have this total displacement. We need to solve this one. Okay, we'll do that one. Now let us look at this problem here, the third part of it. Calculate the distance traveled by the car. Now, how do you calculate the distance traveled by the car? You can calculate it. You need to get the value of u. Yes, sir. So which is nothing but you can use u plus v divided by 2 multiplied by t. Which equation is this? Average velocity equation. See here. V average multiplied by t is equal to s. Okay. So I'm going to use this equation. So I'm substituting u is equal to 0, v is equal to 16 divided by 2, or maybe I take up this value, substitute over here, multiplied by time. What is the total time taken? Total time taken is 8 seconds. 8 seconds. Multiply this by 8. So how much do I get? 2 ones are, 2 eights are, 8 eights are 64 meters. 64 meters. What is this now? This is the total distance traveled by the car. Since he has not given whether the car is moving in a curved path or anything. Moreover, acceleration is constant, so it should move in a straight line only. So therefore, displacement and distance are one and the same. Okay, why do I need this? Because I told you, we can calculate the average velocity by another formula. The second question. Let us try with this. So I should get the same answer once again. So I'll take the 64 meters, substitute over here. 64 divided by total time taken. What is total time taken? Total time taken is 8 seconds. 8 seconds. So I will get once again as 8 meter per second. Thus you see, the average velocity has been determined using 2 different methods. Now, in a similar way, we will also calculate the distance traveled by the car in one more method. Why one? We will try by 2 more methods. Okay. Now, the next equation I'm going to use for calculating the distance, there's one more equation which you have learned, which is nothing but ut plus half at square. Let us see whether we will be able to use this. Now, what is u? U is equal to 0. See, I have taken u equal to 0 already. 0 into t plus half into a. What is a? Value of a. What is a? We have already determined the value of a. A value is 2 over here. Okay. So I will substitute this value half into 2 multiplied by t. T is what? 8 square. 8 square. So when I do this, what do I get? I get this as this 2 and this 2 goes away. 8 square is 64 meters. Wow. See, we have got this answer also. Let us try by one more method also. Why? If there are many equations, we have to try by all the equations. Okay, the third equation, which one will you use? We'll use v square is equal to u square plus 2as, right? This is one more equation of motion. So v square, what is v square? What is the value of v? We have taken 16 here, right? So 16 square is equal to u square, 0 square plus 2 multiplied by a. What is a? A is 2. 2 multiplied by s, right? S we need to find out. 16 square is what? 256. 256 should now be equal to 4 times s. S should be equal to 256 divided by 4. Now, what is the answer here? 4 6 are 24. 4 4s are 16. 64 meters. See, we have got the same answer for using all the three equations. Either of these equations you can use, nothing wrong, because you need to understand that these are the equations that you can use it whenever the acceleration is constant. Though I have completed the problem within 2 minutes, but it will take some time. Do rewind it and get to know, okay, how to solve this particular problem. Right? Have you used everything? Yes, we have used all this. We have used v equal to u plus at here, s equal to ut plus half at square, v square equal to u square plus 2as, v average, yes, see, all the formula has been employed. Okay, let me proceed further. A new model Volvo car can start from rest. Second problem. Can start from rest, which means what? U equal to 0. And travel 400 meters. Value of s is given to you. Okay. And 16 seconds, in 16 seconds, t is given to you. What is the average acceleration during this time? What is the average acceleration? See, so far you had been learning only about acceleration. Now suddenly I have introduced a term as average acceleration. Hey, what is this average acceleration? What is this acceleration? That's what we need to know here. Now acceleration is given by the formula v minus u divided by t. What is average acceleration? Average acceleration tells you average tells you that if you put some value of t, for example, I want to find out the acceleration only when the velocity changes from 3 meter per second to 2 meter per second. Okay, 2 meter per second to 3 meter per second in 1 second in a given time interval. In that case, I can say average acceleration. Now towards it. Now, how do I do this? Now so value of u is given, s is given, t is given. I need to find the value of a. Now, anything else you need here? So u is given, v is not given here. So you will not be able to use v equal to u plus at. Let me keep my photo somewhere here. Okay. So you cannot use v minus u divided by t is equal to a. You cannot use this. Then which other equation you have? Let us use v square equal to u square plus 2as. Can I use this? V is given. No, v is not given. So this also you cannot use. Then can we use s equal to ut plus half at square? Let us see this. S is given, u is given, t is given. Only thing is here is being found out, right? So in these equations, you see v is a hindrance over here. You get two parameters. Two parameters, one equation, you cannot do it. Okay. So this equation is possible. Now let us use this equation. Now towards it, let us use s is equal to ut plus half a t square. What is s? 400 meters. Should be u. What is u? 0. 0 into t, 16, plus half into a. What is a? I do not know. T, what is t? 16. 16 square. 16 square. Which should now be equal to 400 should now be equal to 0 plus half into 16 square is what? 256. So what will this be? This will be, and there's an a here. I need to write it down here. So now 2 1s are to 128. This will be 128 times a. Our a should now be equal to 400 divided by 128. Let us calculate what is this value. So, see, I'm also getting addicted to this calculators. After being with you guys for a long time, I was not at all using calculators in my school days or college days. But unfortunately, after joining I've been using this. You get this as 3.125 meter per second square. This is what is the answer I get. Now, one more thing you see here, this has two significant figures. This is one significant figure here. So this has, I have written this in the 4 decimal places. But remember, you should write it in appropriate significant figures. What is a significant figure here you should write? You should just write this as 3 meter per second square. Put a tilde here. Put a tilde here. Put a tilde here and put a equals over here. So this is what it is. Okay. So we have got an expression for the acceleration. Did we do it correctly? Just re-verify it. I put the values of S here, 16 square, half A. That's right. Okay. Now calculate the final speed of the car. Someone is breaking. Oh my God. Okay. Calculate the final speed of the car. We need to find out the value of V. Now, how do you find the value of V? You can find the value for using V equal to U plus AT. Is everything given to us? Let us find out. A, we have already calculated A. A is known. T is given to you. U is also given to you. Okay, you can find out that. Okay, now let us start with this. So therefore, V is equal to U plus AT, and thus I'll substitute V equal to 0 and A is equal to 3 multiplied by T. What is the value of T? Value of T is 16 seconds. 16 seconds, 16. So which should now be equal to 48 meter per second. This is the final speed of the car, right? Okay. Now, can we do it by any other method? I don't want to do it only by one method. I want to do it by several methods so that you also get conversant with it. Now, we are using this V in one more equation. Which equation? V square equal to U square plus 2S, right? Let us use this also. U square. Put U equal to 0 plus 2 into what is A? 3. What is S? Is the value of S known to us? S value is known, 400. Wow, this is also given to you. So we'll substitute this 400. So what do I get here? 2 into 3, 6 into 4. 6 into 400 is what you get here. What I will do is, I need to have, I'm doing it correctly, right? 2 into 3 into 4, yeah. 6 into 4 is nothing but 24 into 10 square. So V square equal to so much. Now what we need to do is, okay, so finally, when we take the value of V, you'll get a different answer. Let us see, why do we get this? Okay, so you get the answer as 24 into 10 square, which should now be, what is the value of root 24? Root 24 is, just a moment, square root of 24 should be 4.89, which should be 4.89 into 10, which should be 48.9. Here, how can it be? See, here you get 48, here you get 48.9 meter per second. What is the reason? Can you think of this? Okay, so I'll tell you the reason. Just pause the video for 5 minutes and then think about it. Okay, so 1, 2, 3, 4, 5. Okay, let me give you the answer. So the answer is because you see, this velocity here is dependent on time here. I have not used the distance here. Now here the acceleration is dependent on the distance. See, so you have S is equal to ut plus half it. You have calculated this. Now you have approximated this here. Okay. As a result of it, you are finding the difference over here. See, here it is dependent on distance. Here it's dependent on time. Okay. And while the acceleration in both the cases is not the same. So acceleration is not taken independently. Acceleration here is dependent on the distance, which you got a different answer here. Okay. And you are approximated with respect to the distance. Okay. So as a result of it, you are getting incorrectly. Now, what we do is, let us, why is this coming in between? Right. Okay. Now what I will do is, let me use the correct value, 3.125. Okay, without approximation. And let me get this answer here. So towards it, now V is equal to 0 plus 3.125 multiplied by 16. So what is the answer I get? I get this as 3.125 multiplied by 16 is 50. So I get the answer here as 50 meter per second. 50 meter per second. Now, if I do it using this method, so what do I get here? So let me write it down. Where do I write? Okay, I'll write it here. So I will get V square is equal to 2 into 3.125 into 400. Now what do I get here? I should get the correct answer. I hope it comes correctly. If not, 2500. 2500, and thus V should now be equal to square root of 2500, which is 50 meters per second. Wow, success. Okay. So for us, we need to get the correct answer. We do by any method, you should get it correctly. So V is equal to 50 meters per second. So we got it by two methods. Okay, remember this. Okay. So whenever you have something like this, you are approximating it and you're plugging it by into some other equation, which is independent of the value of S. You calculate the value of A based on the value of S. Okay. But if this is your input, if this input goes as this is an output for the previous problem. If this output goes as an input for the next problem, see to it that this equation also has a dependency on S. Okay. So for example, 400. And here, if it is not there, then take the accurate value and then substitute. This is the lesson that you need to learn. Okay. Very useful actually. Many times. Now we have done it by two methods. This is your method one, and this is your method two. Is there any other method to do with it? Is there any other method? I think I can do it by one more method also. We have used which one? V equal to U plus AT. We have used V square equal to U square plus 2A as we used. Let me use another method also. Now we know that S is equal to U plus V divided by 2 into T. Let us do it using this also. What is S? 400 meters. This should now be equal to, this is your method 3. Method 3. Okay. 400 is equal to U. What is U? 0. What is V? What is V? V. We calculate, okay, we do not know the value of V. We do not know the value of V. Divided by 2. Multiplied by 16. Multiplied by 16 seconds, right? 16, yeah. Okay, so therefore, now let us calculate the value of V. V should now be equal to 800 divided by 16. What is this? 16 ones are, 16 fives are, which should once again be 50 meters per second. Wow. Great, right? I'm not great. The one who discovered these equations are great. Okay, so nicely you can use by any method and still it works for you. Okay, but I always advise you, okay, try with all the methods and see to it that you get the same answer. That really gives an interest in solving problems. Okay, now let us proceed further. Now, how fast is this final speed in kilometer per hour? We need to convert this one into kilometer per hour. How do I do? 50 meter per second to kilometer per hour, dash kilometer per hour. How do I do this? So what you need to do is, if it is in kilometer per hour, and I want it in terms of meter per second, then what do you do? Whatever you have this, you multiply this by 5 by 18. Okay. But if you want to do the reverse one, you should multiply this by 18 by 5. Okay. So 5 ones are 5 tens are, and thus it will be 180 kilometer per hour. Wow. 180 kilometer per hour. Does our Volvo car move with that speed? I was not aware of this. 180 kilometer per hour means Chennai you can reach within 2 hours. Do you think it's possible? Chennai is around 360 kilometers from here, and reaching there within 2 hours is an impossible task. Why is it impossible? Think about it. Let me know the answers in your comments, so others can also get benefited. Okay, so the question here is that if you have a Volvo car which can travel at a rate of 180 kilometers per hour, why is it not possible by anyone who travels with a Volvo bus to reach Chennai from Bangalore in 2 hours? Usually the Volvo buses that we travel from here, I think I left, maybe it takes around 5 hours, I think. 5.5 hours it takes. Okay, not below this. Okay, think about this. Then you will get an answer for it. Okay, now let us move on to the next one. A space rocket is launched and accelerates from rest to 160 meters per second. Okay, let us read this slowly. Now, just a moment. Okay, back. A space rocket is launched and accelerates. Is launched, which means what? Initially, a rocket was just standing at some point, and then you launch it, which means the initial velocity was 0. From rest, it's already given. U equal to 0 to 160 meters per second. Very, very speed. V is equal to 160 meters per second. And it accelerates uniformly, which means you can use your equations of motion. Okay. In 4.5 seconds. The first thing in any problem, in any physics numerical, is that identify the parameters correctly. If you do this, 50% of your problem is solved because you get an idea of what to do. Okay, next, calculate the acceleration of the rocket. What is the acceleration? Simple. Acceleration is nothing but v minus u divided by t. Substitute the values, which is 160 minus 0 divided by 4.5 seconds. What is that value? Do it fast, do it fast, do it fast. 160 divided by 4.5 will give you 35.56 meter per second squared. Now, here you see two significant figures. Here it is two significant figures. So this should now be represented only in terms of 35, or you can, since 35.56 you're getting here, make it as 36 meter per second squared. Okay, this should be the answer. Then, how far does a rocket travel in this time? What is the distance traveled by the rocket? What do you think it would be? Maybe 1 kilometer, 5 kilometers? Okay, let us calculate it. Okay, by looking at it, we can say, hey, yeah, it has gone to several billions of kilometers. No, it's not true. Okay, let us find out what distance does it travel. So how do I travel? How do I consider this? First one is distance, yes, is equal to u plus v divided by 2 multiplied by t. Okay, easiest way to do it. What is u? 0. What is v? V is 160 divided by 2 multiplied by, I will substitute the whole thing here. Okay, now it's dependent on time. Let me take the accurate values. 35.56. When I do this, what do I get here? I get 80 multiplied by 35.56. I'm going a bit faster, but you can always reduce the speed in your video and then you can have a look at it. 35.56, which tells you it is 2844.8. 2844.8 meters. In other words, how much is this? This should now be equal to 2.84 kilometers. Very short distance here. What is this? 2.84 kilometers only it moves. Nothing great. Are we doing it correctly? No, we're not doing it correctly. We're not doing it correctly. Why is it not correctly? Because you see, I have substituted the incorrect value here. You know, sometimes teachers also make a mistake. Okay, it is incorrect. Let us redo it once again. S is equal to u plus v divided by 2 multiplied by t, which should be 0 plus 160 divided by 2. This time I should do it correctly. 160, correct, right? 160 multiplied by 4.4. See, this is where I made a mistake. I'm just thinking, how come within 4.5 seconds it moves that much distance? Impossible. Then I realized my mistake. So this should be 80 multiplied by 4.5, which is only 120 meters. 120 meters. It moves only by a distance of 120 meters. Yeah, I think so. Hey, what is this? I am sorry. Once again, I made a mistake. Oh my God. What is this? Making lots of mistakes here. 80 into 4.5 should be 360 meters. Simple mathematics. That's what happens when we use calculators, you know. We'll get confused. It will say whatever it is and we'll just substitute that value. Okay. So it is not even moved by half a kilometer. Okay. 360 meters only it moves. Are there any other methods to determine this? Yes, we have one more method. Let us verify it by the second method. What method is this? We'll use S is equal to ut plus half at square. Ut plus half at square. I should get the answer now. Now, what's the value of u? 0 plus half into a. I'll use the exact value here. Last time itself I made a mistake. Multiplied by t square. T square, what is 4.5 square? 4.5 square. So this should now be equal to, what is the value here? 35.56 multiplied by 4.5 multiplied by, oh my God, I made a mistake once again, just a minute. 35.56 multiplied by 4.5 multiplied by 4.5 5 square divided by 2. I get the answer as 360.045. 360.045. Okay, so almost it is 360 meters. Okay, same as this one. Are there any other method apart from it? Oh, we have one more method. See how many methods we have here. And mechanics is very easy. Now, which method? We'll use v square is equal to u square plus 2as. We'll use this method also. Okay, so v. What is v? Final velocity. Do I have final velocity? 160. We have this 160 square. Should be equal to u square, 0. plus 2 into A. What is A? 35.56. 35.56. 35.56 multiplied by S. I want the value of S. So S over here. So now let me find out using this method also. Do I get the same answer? So I will write S is equal to 160 square divided by 2 into 35.56. So what is this? 2 into 35.56, which is 71.12. 71.12. If I calculate this, multiply this by 160 square. 160 into 160. I'm making some mistake. I'm not getting what is wrong. What is it? Let me just recheck it, verify it. I'm not getting the correct answer. Okay, let me redo it once again. What is wrong with this? I got it here. The answer I'm getting here is 359.96, which is once again closer to 360 meters. Okay, so by all the three methods, we have got this exactly to be around 360 meters. Okay, now I hope when you start working on these equations, you will get to know how to employ the equations of motion. Then, what is the final speed of the rocket in kilometer per hour? Oh, final speed of the rocket in kilometer per hour. What is the speed we have calculated? 160 meter per second. It's already given. Okay, so therefore you need to convert 160 meter per second to kilometer per hour. We already done a similar problem earlier. What do? We just multiply this by 18 by 5. 18 by 5, yeah, not 15. No, sorry. 5 by 18. 160 multiplied by 5 by 18. What will I get? I get this as 18 ones are hurry. How do I do? Let me use my calculator here. Otherwise, simply unnecessary problems. Into 5 divided by 18 is 44.4. Wow, 44.4 kilometer per hour. Once again, this should be kept in appropriate significant figures. Otherwise, I will cut marks for this. Now, how many significant figures? Here 2, here also 2. So I will keep this only as 44 kilometer per hour. 44 kilometer per hour. Here also, you see, I kept this at 360. And here also, I should not write so much. I should write this as 360 meters only. Okay, two significant figures. Okay, so we have done the third one. Now, let us look at the fourth one. A driver plunges head first into a diving pool. Oh my God, not driver. Okay. Why should a driver plunge? That's what I was thinking. If you ask me to plunge, I will not do it. While traveling 28.2 meter per second, while traveling at 28.2, that means its initial speed is given. 28.2 meter per second. Upon entering the water, the driver stops within a distance of 4 meters from the diving board. Wow, you stop somewhere. This is a diving board. Upon entering the water, the diver stops at a distance of 4 meters. He travels all the way along until here. Thank God he doesn't hit it. Good. Okay, 4 meters. Consider diver to be a single point located at the center of mass. Why he has given this is because a diver is generally his length or his height is around 5 to 6, 5 to 7 meters, 5 to 7 foot, not meters. Sorry. Okay, so as a result of it, if you have a diver to that much extent, okay, so how do you approximate it? If you say he is at a distance of 4 meters, then you will ask a question. Okay, is it from the leg or is it from the foot or okay, is it from the head or whatever it is? So it'll be quite difficult. So he says, okay, consider this to be a single point. Okay, then locate at the center of mass, assuming her acceleration through the water to be uniform. So acceleration to be uniform, which means what? He is giving you a clue saying that you can use equations of motion. Okay, now, so what is that we need? So he says he stops here. When you say stops here, v equal to 0, value of u is given by 28.2. What to be found out? Average acceleration. What do we do? What do we need to do? Get the value of a. How do we find the value of a? Can I use v equal to u plus at? Definitely not. Why? Because the value of t is not known to me. Right? Now, can I use v square equal to u square plus 2as? Now, v square is equal to u square plus 2a into s. Yes, this can be used. Okay, let us try with this. So, therefore, now 2as plus u square is equal to v square. Now u square, what is u square? 28.2 whole square. 28.2 whole square. Kilometer, no, meter per second. Plus 2 into a. What is a? A is what you need to find. I do not know. What is the value of s? 4 meters. This should be equal to 0. So thus we have 8a is equal to minus 28.2 whole square. Where is my calculator? 28.2 multiplied by 28.2 is 795.24 divided by, okay, so I get this answer as minus 795.24. The value of a thus is equal to minus 795.24 divided by 8, which should now be equal to 99.4. Minus 99.4 meter per second square. Itna jada? Okay, fine. Minus 99.4 meter per second square. And what do you call this acceleration as? It's a deceleration. Now, how many significant figures? So here, 4.00, which means what? It is one significant figure here. Here, three significant figures. What should your answer be? Only one significant figure, right? So approximate this to 100 and write this as minus 100 meter per second square. This should be your answer. Don't place it in minus 99.4. Here we are not giving marks for accuracy. Here we are giving marks for your presentation skills. Okay. Then how long does a driver take to come to a stop? How long? How long means what? What is the time taken by the driver to come to a stop? Is the time given? No, you need to find the time here, right? Okay, so therefore, now let us find the time. How do you find the time? First equation is, you can say S is equal to U plus V divided by 2 into T. Okay, this is the easiest way. Now what is S? S is already given to be 4 meters. 4 meters. What is U? 0 plus, this is your first method. First method. Plus V. What is V? V, 28.2. Sorry, U is equal to, oh, I'm sorry, this is to be 28.2 plus V should be 0 divided by 2 multiplied by time taken, which we do not know, which we need to calculate. Now get the value of this. So let us find out what is this value. Now the answer is 4 into 2, 8 divided by, so what I will do is I'll multiply this. Okay, I'll take it directly here. 28.2 divided by 28.2 divided by 2 will be 14.1. So you get 4 is equal to 14.1 times T. T should be equal to, how much will this be? I don't know. There's something wrong with my calculator. It wants always to fail me up. It's giving me 256 seconds. Yeah, what? Is it sleeping or what? 256 seconds. Now you are getting it. 0.283 seconds. Okay, this is the answer that you should get. So the best way, now once again, significant figures, the best way to represent this is, you should cite this as 0.3 seconds, one significant figure. Okay, then any other method? Let us do by another method also. What do we need? Time over here. Which equation can we use? Can we use V minus U by T equal to A? Yes, you can use it. V is equal to U plus AT. Now what is V? 0. What is U? U is, what is the value of U? 28.2. 28.2. Plus, what is A? A is, what is the value of A? We have got A here, right? Minus 99.4. Okay, minus 99.4. Minus 99.4 multiplied by T. What is T? T is not unknown to me. That's what we need to do. Okay, so thus now I will write this as 99.4 times T is equal to 28.2. T should be equal to 28.2 divided by 99.4. And let me calculate this value. So now I have 28.2 divided by 99.4, which I get this once again as 0.283 seconds, which is once again 0.3 seconds. Okay, so this method is also works well. Okay, so this is also correct. Then shall we do by any other method? Where do we get T here? Which equation we have used S, we have used V here, and we have S equal to UT plus half AT square. Wow, we use that method also. S equal to UT plus half AT square. Now, what is U once again? U is, what is S? First write the slide. 4 meters. U is 28.2. I do not know the value of T. I need to find this value plus half into A. What is A? What's the value of A? We are substituted here, right? Minus 99.4. Minus 99.4 multiplied by t square. Wow, big equation here. Okay, let us try. Anyway, we are not going to break the laptop here. So this should now be, how do I solve this? 28.2t minus 99.4 divided by 2. 99.4 divided by 2 should be 49.7 minus 49.7 into t square. This is what I have got. Oh my God, this is but big equation. The moment I see itself is spinning my head like anything. Okay, let us try. 49.7 t square minus 28.2 t plus 4 is equal to 0. What I have done is I have taken all these parameters to that side so that I equate it to 0. Now you see, this is nothing but your quadratic equation. I hope you have learned about quadratic equation, which tells you it is ax square plus bx plus c equal to 0. What is the solution for this equation? Solution for the equation is, roots of the equation is x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Wow. See, one fellow somebody has easily discovered this. Quite easier for us. Minus b. So minus of minus b is negative here, right? Minus 28.2. So I'll substitute here. It becomes minus of minus 28.2 plus or minus square root of b square. What is b square? Minus 28.2 the whole square. Minus 28.2 the whole square plus 4ac. 4 into 49.7 into c into 4. Okay, whole square root divided by 2a. What is 2a? 2 into 49.7. 2 into 49.7. Oh my God, I don't have space for this. Okay, so let us try with this. Minus into minus becomes 28.2 plus or minus square root of. I'll try the whole answer here. So you can verify your calculations because I don't have much of space over here. So this should be 28.2 into 28.2 whole square is done. That should be equal to 795.24. 795.24 plus 4 4s are 16. 16 multiplied by 49.7 will be 795.2. Yes, same answer I'm getting. 0.2. Anyway, so divided by 2 into 49.7. 49.7. Okay. Now you see this is 2, 4, this is 2. Anyway, I'll take it same here. So I'll get the answer 795.2 only. 795.2 square root. Okay, I'll give the full answer. I'm not going to do it separately. So now this should now be equal to 795.2 into 1.41. I have taken root of 2. See, I get two answers here, 28.2 minus this one and plus 1. Okay, so I'm not going to the negative sign. The reason is because here, instead of x, we have put t here. Okay, so t cannot become negative. So there's no point in taking negative answer. Don't take negatives. No negative types, right? So what do I get here? 1.4. I'm writing the full answer. You can verify it yourself because you might also have a calculator. So I am not going to do this personally. Divided by 2 is equal to so much divided by 49.7. I get this as 11.56 seconds. Oh my God, this is completely incorrect. What went wrong? Something went wrong. Huh? What went wrong? You know what went wrong? Something has gone wrong. What is wrong? Sign conventions went wrong. Whole thing goes away. I tell you what went wrong. I also didn't take a notice of this. Whole thing went wrong. Okay. Anyway, we'll do one thing. We are satisfied with these two answers. This method is a bit lengthier, but if you want, maybe at the end, okay, I can show you this answer here because I don't have much space. This definitely takes a long space for me. Okay, now let us continue with this problem here. What is the speed of the diver after she has dived for 2 meters? So you can use v square equal to u square plus 2as because t is not given. T is not asked. It's only for 2 meters. U, what is u? 28.2 whole square plus 2 into, what is the value of a? What is the value of a? Value of a. minus 99.4. Minus 99.4 and multiplied by 2 meters. So if I do this, so what is the answer that I get? I get the answer as, just a moment, 4 into 99.4 will be 397.6 minus 28.2 the whole square. 28.2 square. I get the answer as 397.64. 397.64. V square equal to 397.64 close to 400. 400. So which means V should now be equal to 20 meter per second. 20 meter per second. What was the initial velocity? 28.2. Now it is reduced to 20 meter per second. Works well. Okay. Now let us look at the next one. Okay. When does a car have the greatest ability to accelerate and gain speed? When it is moving slowly or when it is traveling fastly? No equations required here. You need to understand this. When you're traveling in a car, okay, let us say you're traveling at 60 km per hour or maybe 80 km per hour. Okay, now you say you press your accelerator pedal and then you want to find out whether you can travel at a much higher speed. Is it easy for you? No, it doesn't, right? Because 80 can go to 82, 84, but takes a long time to accelerate. While if you're traveling at something like 20 km per hour and you want to accelerate, you want to move to 40 km per hour. Now what will happen? The moment you push on the accelerator pedal, automatically its speed increases, right? So therefore, it's more easy to accelerate when you're moving at lower speeds as compared to higher speeds. So why does this happen? The reason is because, see, when you're moving on a car, you just put your hand outside the window shield. Then what do you observe? You will feel the gush of wind which is blowing your palm, right? The speed of wind will be, you can feel it. Now, which means that there's an air resistance given there. So even though the car is just an engine, but it will have a negative force. You're not applying brakes, you are pushing only the accelerator pedal. But there's an air resistance given at a higher speed. Okay. While when you're traveling at a lower speed, the air resistance is much smaller. Okay. So it's easy for you, okay, to increase your speed with the same accelerations, okay, at lower speeds as compared to higher speed. Now, what do we write now? We have understood the logic here. We need to write. When does a car have the greatest ability to accelerate? He is asking you the command term when. If the car travels at lower speeds, it's easier to accelerate to higher speeds. This is known to us. Okay, and then when it is moving slowly, okay, so we have answered the question. Then explain. Okay, there are two comment terms over here. Definitely this should be asked for 3 marks. Okay, explain. What do you mean by explain? While you say explain, so what do you suggest here? You should say that at lower speeds, wind resistance to the motion of car. Instead of writing motion of car, you can also say accelerating car is lower as compared to the wind resistance, when it is moving at higher speeds. We have explained this also. I hope you understand this. If any of the questions, if you do not understand, do mention your comments. I can help you out with another video. Okay, now let us move on to the next one. A cyclist, while overtaking another bike, increases the speed from 4.2 to 6.3. What is your initial velocity? U. U is this one, 4.2. And what is V? 6.3. Over a time interval of 5.3 seconds. Direct question here. Okay, so he's asking you the acceleration of cyclist. Simple answers. So what you can do is you can say acceleration A is equal to V minus U divided by T. which should be 6.3 minus 4.2 divided by 5.3. All big numbers. It's not so easy to calculate this. Let us see. 6.3 minus 4.2 should be 4.2, 5.2, 6.2, 2.1. It should be 2.1 divided by 5.3. Now let us calculate this. So 2.1 divided by 5.3 should be 0.396. 0.396 meter per second square. How many significant figures? Anything. Okay. It should be in significant figures. 2 here. So this should definitely be 0.396 should be 0.40 over here. Remember to put the value of 0 here. If not, you'll get only one significant figure, which is incorrect. Okay, so you write the unit. If you miss a unit also, you lose the marks. Right. And then how far does a cyclist travel while overtaking? How far does he travel? He's asking you to find out the S value. Easiest way is U plus V divided by 2 into T. I'm not going to do the rest of the methods. You can try using this. So U, what is U here? U here is 4.2 and V is 6.3. 4.2 plus 6.3 divided by 2 multiplied by T. What is T? What is T? What is T? T is 5.3. 5.3. 5.3. So let us calculate this. We work lots of work over calculators. 4.2 plus 6.3 is 10.5 divided by 2 is 5.25 multiplied by 5.3. Should be 27.825. 27.825 meters. Now, how many significant figures? 2 significant figures. So what should I do? This can be approximated to 28 meters. Okay, fine. Now, what is the average speed of the cyclist during this time? Simple. 4.2 plus 6.3 divided by 2. What is it now? Which should be 5.25. 5.25 meter per second. Now, how do I write it? I should write this as 5.3 meter per second because 2 significant figures. Then, wow, we have come to an end to it. Great. Now, you should pay my tuition fee for this. Okay, fine. Thank you all for watching this video because we don't have much of time. So I thought doing a video will definitely help you out. All do like, share with your friends, whoever is in need of understanding the equations of motion. So these are really wonderful problems. And comment and subscribe to my channel. Ask your friends to subscribe, which would really help me out. Okay, definitely, we are all doing a business. So in monetizing my channel. Thank you.